Thanks to NASCOM for this opportunity to present what we are doing over here. So, I'm the co-founder of Hydrovert, and basically at Hydrovert we are developing hydrogen fuel cell powertrains for a variety of applications, which includes mobility as well as stationary power generation. And the first question to ask is why hydrogen for mobility? And one of the, as we talked about the transition towards clean energy, so that is the centerpiece, the main reason why we are looking at alternative options to ICE engines, which are run by petrol and diesel. And the main issue is that the world currently is looking for good alternatives to diesel and petrol powered vehicles, which on all other technical fronts perform very well. Their only main challenge is that they release various pollutants when they are being operated. And we feel that hydrogen fuel cell powered vehicles are a good alternative to ICE engines, which offer the same performance in terms of the driving range, the refueling time, as well as the payload capacity, so they don't compromise on any of those attributes of these vehicles, while at the same time being non-polluting, like EVs. So hydrogen fuel cell vehicles are zero emissions, reliable and safe. And with the powertrains that we are developing for mobility applications, we are mainly focusing on giving a long driving range, which is what is required by all commercial fleet operators and vehicle users. We also want to develop a powertrain which can give a very high payload capacity. Our main target markets are cargo vehicle applications, where the payload is very important. At the same time, we want to develop a solution which is similar to ICE engines in terms of the refueling time. So the fleet operators and customers and vehicle users, they appreciate the fact that you can go to a refueling station and refill a petrol or diesel vehicle very quickly. And we want to replicate that with the hydrogen fuel cell powered vehicles as well. And while doing all this, fuel cell vehicles present a zero emissions solution. So our core product is the powertrain, which consists of all these various systems working together. So it can be thought of, the hydrogen fuel cell can be thought of as the engine of the vehicle. It consists of a cylinder which stores all the hydrogen at a very high pressure. There is a fuel cell which takes this hydrogen, oxygen from the air, and converts that energy into electricity. And what we are developing is a hybrid system. So it is a fuel cell and a battery working together. Battery allows you to give quick acceleration, absorb the regenerative braking power, while fuel cell is the energy component of it. So it recharges the battery when you go into cruising mode at driving speeds. And so what this system does is that instead of having to recharge the battery, you have this fuel cell which automatically recharges the battery, and we only have to go to a fueling station and fill the hydrogen to be able to drive the powertrain. And in addition to this, it also consists of one of our core IPs is the power electronics system, which manages the power flow between the motor, the battery and the fuel cell. So it dynamically decides when to recharge the battery, when to use the fuel cell power directly for powering the motor and so on. And a lot of our efforts and IPs have been directed in this. And secondly, one of our major targets is also to think about safety. So we have spent the most amount of time thinking about the safety of the hydrogen and how it can be made more reliable in case there are accidents or in case there are any other issues on the road. The system should be able to manage all those accident conditions in a safe way. So the first deployment of our powertrain we have done on this hydrogen powered motorcycle which you see here. And the entire powertrain has been deployed on this, including the cylinder, the fuel cell, the battery. And this is a working prototype which is currently under testing where our workshop is located in the NCL Innovation Park in Pashan in Pune. And we have loaded this prototype with a lot of measurement devices, because we are doing a lot of measurements to be able to capture all the data while it is being driven on the road. And we use that data to improve the performance, to understand the limitations and solve some of the key challenges which we are facing. And mainly we want to use this data to improve the fuel efficiency. So the more we can improve the fuel efficiency, the lower will be the operating cost of using the vehicle. In addition to this motorcycle, we are also working on hydrogen powered three-wheelers, cargo three-wheelers. Here in this slide we have done a direct comparison of using hydrogen in comparison to using CNG or diesel as the fuels. So compared to CNG and diesel usage as fuels, even if you consider the cost of hydrogen today, which is 300 rupees per kg, it turns out to be a much more economical option. The only remaining challenge is that hydrogen should be available at refueling stations, so that vehicles that we and others are developing using hydrogen fuel cell technology, they can be refueled, and if that happens, then that will be an economically viable alternative and non-polluting alternative to CNG and diesel vehicles. So the powertrains is our core product, and the powertrains which we are developing, that is basically you can say a device which converts the energy stored in the hydrogen to electricity. And along with cargo three-wheelers, there are many other applications which we are also targeting. One of them is stationary power generation. So the powertrain packaged differently is usable as a stationary power generator, which is a direct replacement for diesel generators. The same powertrain can also be deployed with little to no modifications for marine vessels, for giving a long range and quick refueling attribute to those vehicles as well. And the same powertrain can also be used for material handling equipment, which are used a lot in the industry, and they are often battery powered because they need to be zero emissions since they're operating within closed environments, but we can also make them hydrogen fuel cell powered, in which case they can run for a much longer time without having the need to refuel or recharge in between. So some of the planned pilot demonstrations of our powertrain, the first one that is coming up is that we'll be deploying our stationary power generator at the Greater Noida location of NTPC, where they already have set up electrolyzers for producing green hydrogen for running buses between Delhi and Agra, and we'll be deploying our stationary power generator there, and it will directly take hydrogen from the green hydrogen that they are producing and produce electricity from that for serving the lighting loads within their office. So these are some of the awards and grants which we have received in the past 3 years of our existence, and they continue to support a lot of the work that we are doing. And our team consists of myself, the co-founder, and Ms. Supriya Patwardhan, who's also the co-founder. She is also here present in the audience, and she's looking mainly after the strategy and the business part of the company. We also have our engineering team here, consisting of Nitin, Pooja, and Ayush, and you can also interact with them regarding the system and the actual motorcycle which we have developed. So thanks a lot again for your time and attention, and thanks NASSCOM.